Hi everyone! Today I'm gonna help you answer the following question: how to choose the right statistical test. To answer this question, we need to know the type of variables, samples, hypotheses, and tests. This slide shows there are two types of variables: quantitative and qualitative. The quantitative variables are defined as scale in SPSS and can be continuous, such as the weight and the age, or discrete, which means discontinuous, such as the number of children, pieces, and parts. So, the discrete variables don't accept commas, otherwise we cannot say a person and a health. The second category is the qualitative variables, which include two types: nominal, like sex, color; ordinal, like size for clothes. So, every nominal variable that respects an order is classified as ordinal. Concerning samples, we have two types of samples: dependent and independent. The dependent sample includes repeated measures, like the weight during the first week versus the weight during the second week, which means in general at least two columns for the same variable, which is the weight in this case. The independent sample presents the same data, but separated by a qualitative variable, like the age for boys versus the age for girls. This means n rows versus n rows in the same column, which is the age in this case. In statistics, we have two types of hypotheses: a hypothesis of equivalence or null, noted H0, which varies according to the study objectives. If the p-value is greater or equal to 0.05, we will accept H0 and say there is no significant result. For example, no correlation, no association, no difference, etc. In case if we are comparing two means, H0 will be expressed as M1 equal to M2. The second hypothesis of non-equivalence or alternative, noted H1, has two expressions according to the test if it is unilateral or bilateral. If the test is bilateral, H1 is expressed with the symbols of difference. For example, in the case of two means, we write M1 is different from M2. However, if the test is unilateral, H1 is expressed as two possible inequalities: M1 is less than M2 in the case of left unilateral test, or M1 is greater than M2 in the case of right unilateral test. So, for unilateral tests, we divide the p-value by 2 because we perform the analysis only on one side and not two sides, or two-tailed, as we do for bilateral tests. The normality of distribution allows us to know if the test to be chosen is parametric or non-parametric. The test the most useful to test the normality is the test of Kolmogorov-Smirnov, noted KS. If the p-value is less than 0.05, we say that the variable values are not normally distributed, and we apply non-parametric tests such as Wilcoxon test, Mann-Whitney test, etc. The criteria of normally distributed variables are the following. First, distribution represented as a bell. Second, mean and median have approximately the same values. Third, kurtosis and skewness coefficients are null or close to 0. After we highlighted the difference between variables, quantitative or qualitative, samples, dependent or independent, hypotheses, null or alternative, and tests, parametric or non-parametric, we became able to choose correctly the statistical test according to the study objectives and the database. This table shows how to describe, compare, quantify, and predict variables according to the study data. To describe quantitative variables, we use means and standard deviations in the case of normal distribution, and we use median and interquartiles or percentiles in the case of non-Gaussian distribution. However, the qualitative variables are described using proportions, and the survival time data are described using Kaplan-Meier survival curves. In addition, to compare a group to a hypothetical value, we use one simple t-test for quantitative variables normally distributed, and we use its equivalent Wilcoxon test for quantitative variables which don't follow a normal distribution. However, for data with two outcomes, we use binomial or chi-square test. We apply the same technique to read the rest of this table. To compare two unpaired groups, we use unpaired t-test in the case of normal distribution, its equivalent Mann-Whitney test in the case of non-Gaussian distribution, and Fisher's test or chi-square test in the case of data that accepts only two outcomes. And in the case of data for survival time, we use log rank test or mental Hensel. To compare two paired groups, we use paired t-test, Wilcoxon test, McNemar's test, conditional proportional hazard regression. To compare three or more unmatched groups, we use one-way ANOVA, Kruskal-Wallis test, chi-square test, Cox proportional hazard regression. To compare three or more matched groups, we use repeated measures ANOVA, Friedman test, Cochran-Q test, conditional proportional hazard regression. To quantify association between two variables, we use percent correlation in the case of normal distribution, Spearman correlation in the case of non-Gaussian distribution, and contingency coefficients in the case of binomial or two outcomes data. To predict value from another measured variable, we use simple linear or non-linear regression, non-parametric regression, simple logistic regression, Cox proportional hazard regression. However, to predict value from several measured or binomial variables, we use multiple linear or non-linear regression, and in the case of binomial or two outcomes data, we use multinomial logistic regression, and in the case of survival time data, we use Cox proportional hazard regression. Thanks for your attention.